All right, first of all, thanks everyone for coming. This is amazing. What is also more amazing is that we have, in the audience, one of the fathers of Amiga, which is very special.
Thank you.
So, yeah, okay, I'll try not to repeat what I said last time. We already have one video on your website. So you can see from introduction about the MiniMig from the previous year. But I'll try to kind of go through some basics for people who don't know what was done. So if you look at the yellow board, that's original MiniMig that was done by Dennis von Viren. It's the original MiniMig core, FPGA core written in Verilog. That's hopefully cursor is still there. Okay, so this part here has a MiniMig core. That's OCS ECS core, 2 megs of RAM. And what was very interesting, it is that this board has a real 68,000 CPU from Freescale, running at some 7 megahertz up to maybe 30 megahertz. And then project was left there. Original MiniMig was, from 2006 to until I picked up the project, it was the same. And then I started experimenting with the design. And what I did, I added LVDCs here, which are the level shifters. So if you see these parts here, so these parts are actually translating the signal levels from TTL 5 volts to CMOS 3.3, which is new logic, new parts. When you're dealing with those parts, you're dealing with 3.3 volts. So I was able to interface old original Amiga CPU with the MiniMig. And the first challenge was obviously the hardware to make sure that old can talk to the new. So this first iteration was successful, but not quite as accurate. And then second iteration is this one here. And the difference is it's a different type of transceiver. I use CBTDs, BAT transceivers, which are much faster and more accurate. So once I did that, all of a sudden Amiga became alive. I could add, terrible fire 030 accelerator board, and look, it's working. It's just this little change. Of course, it wasn't just this change. Most of the changes happened in the Verilog core, in the FPGA, because there you can adjust the timing, the delay, all the nets, and so forth. So we did a lot of development there. And then finally, this is new. You haven't seen this. Probably since last year, I didn't have this board. That's also original classic MiniMig, but it has 6 megs of RAM. So I did 2 more chips, as you can see, which wasn't difficult because I had 2 available pins, last 2 pins available on the Spartan 3. It's done now. This board is 100% used. The Spartan 3 is about 90% full, so nothing else can be added. So that's about it. That's done for the classic MiniMig. Usually, I thought it would be easy to add 2 megs of RAM, but then I realized this needs to be fast RAM. And MiniMig doesn't have auto configuration protocol implemented in the Verilog, in the chip itself. So that's what I wrote as well. I designed auto configuration, and now the MiniMig will detect the additional 2 megabits of RAM, put it in appropriate space. If that space is used, it will use other space, the memory range. And this is why Amiga was so cool, because if you remember back then, if you had a PC, you would need to have jumpers. You would add RQ, RQ numbers, those hexadecimal address ranges and stuff like that. Amiga does it. It did it from the get-go. It's that auto configuration protocol that's done in hardware. So MiniMig does that as well. And yeah, if you look at the progress, it came from 2 megs of RAM, then 4 megs of RAM, 6 megs of RAM. First, it didn't have voltage regulation to 5 volts, which is really important because you're driving now your CPU at 5 volts. So I added voltage regulation, which is this part here and this part here. So now entire board is regulated really precisely to the, I don't know which decimal, but it's really spot on. And what else was changed? Original board had this little PIC 8-bit microcontroller. when I start working on the board, I replace that with the ARM 32-bit part that actually controls the entire board and loads the core into the FPGA and things like that. All right. So closer look at the board. Processor is Motorola 68000 SEC version that runs at 60 megahertz, which gives the board performance of Amiga 3000, a little bit faster actually. FPGA is still this old Xilinx XC3S 400, which is pretty anachronic the solution, because it's from 2006, which it's funny because this new part is kind of retro as well, and that needs to be replaced obviously. RAM 6 megabytes. The configuration is 512K times 16, 45 nanoseconds. Level shifters are, as I mentioned, CBTDs, transceivers, super fast. MCU is SAM7. This is very common part. Even I think other FPGA boards are using very similar approach. Power, you can do 12 volts barrel jack here in this area. Or because the board is ATX, you can add ATX power, the big one from your PC, or you can use something like this, which is it's called, I think it's called Pico ATX adapter, and then use again barrel jack 12 volts, and this thing will do all the voltage regulation and whatnot, and that works fine. For the oscillator and the counter, it's CD74HC, very common part. RS232 transceiver is SP3232EU. And then switch, you have one switch to shift from 50 kilohertz to 31. Then the other one is fast SPI. So you can choose SPI frequency from 8 megahertz to 24 megahertz in the current configuration. And then there is a serial switch here. So you can change the output of the serial port from Amiga to a debug for the ARM itself. So this little system controller, you can see if MiniMig is doing something weird by switching to the debug serial. And for the headers, I have one header here, actually two headers that I left, serial headers for Wi-Fi, which I'm working on right now. So you'll be able to add ESP32 card here and have Wi-Fi, which is awesome. You can go to the BBS, surf Synchronet or whatever, that helps, and even share the files easily over the network. So yeah, that's about it. So this is from the previous year, the photo from the table. What can this run? It can run your original Motorola 68000 from Amiga 1500, 2000. It can do SEC CPU from Freescale up to 60 megahertz, and it can do HC variant that can run about 30 megahertz. You can do PyStorm and have amazing performance, play Quake and Doom and Duke Nukem and everything else. You can do Terrible Fire cards, test most of those, it works just fine. Even the FPU will be detected, additional RAM, CPU, everything. And then many other cards I tested work just fine. But still we need to do Vampire, which is a big deal. You can get AGA right away on the MiniMig with Vampire. By the way, I do like Vampire. And then Buffy, Rene Cousins is working on Buffy, which will give you about 1,000 plus MIPS on your Amiga, which is very formidable. It will be the little board, CPU board that you can just plug into any Amiga and just get this mind-blowing performance. Super accurate as well, precise timing. And that's all related to the Gary. You probably know there is a chip in the chipset called Gary, which is pretty much the collection of gate arrays. And that thing is giving us a lot of, I don't want to say trouble, but all these problems that we had with the timing, most of them are in Gary. You need to understand that MiniMig was never designed to be real Amiga. It was designed to do the Amiga thing in one chip. So once you start spreading peripheral stuff around and you want to interface, you need to make sure it's not close to Amiga, but it is Amiga. So that's what we're doing now. And by we, I mean mostly Rene. So that's it. The other thing to mention is that MiniMig can run PyStorm in the turbo mode, which means the frequency on the bus will be 60 megahertz. Actually, most of the time 40 to 50 megahertz works the best. And then you'll have amazing chip performance with the PyStorm, which was always the problem with the PyStorm. You remember people are trying to get the chip performance of value 1, which means equal to what it was on Amiga. It was always slightly slower. Well, with the MiniMig, it's 2 times faster. So that's another benefit of this hybrid design that MiniMig has. So a few things about Rene. She helped a lot with the project, helping me with understanding the shifting and transceivers and all that stuff. She's an amazing firmware designer, engineer, and this is Buffy. It's been in works for a while, but it's super difficult, and what she's doing is about what team of people usually do. Creating a new CPU, that's what she's doing. She's creating a new 68,000 CPU that can outperform Pentium 4 pretty much in performance. And she is now spot on with the Gary problems. In fact, a few days ago she told me that she's really close to resolve all these weird issues with the Gary, and that means we'll have compatibility with the Buffy, most importantly, and then Vampire, pretty much with anything. So we'll be able to stick anything in a MiniMig. Also, this is, she calls it Gary Zander. I don't know who Gary Zander is. You probably guys know, I assume. I didn't ask. Anyone?
Okay, it's Andrew Ritz, one of the Scooby Squad in Buffy.
Okay. Okay.
Fans.
All right.
And Buffy, of course, is the vampire slayer.
Oh, that's why. Okay, now it starting to make sense. Yes. So yeah, that's it. Thanks for giving me the answer. But this thing, Gary Zander, is what you're looking at is a replacement for your Gary in Amiga. So it's going to be so accurate and 100% the same thing that you'll be able to take your Gary from your Amiga 1000, or actually I think 1000 has Gary because they did it later. But let's say Amiga 500, and then you can just make a drop-in replacement. At this time, accuracy for the Buffy is about 99.8%, and hopefully within a month or two, this will be done. Okay, so important thing to know, everything that I do, including MiniMig, is open source. You can download everything from the website. You can download the Gerber files, you can make the thing, you can download the software, the core, the Verilog, you can improve Amiga, you can create your own chipset, you can do whatever you like. So you can even sell it. Many people were asking me, you're making this and selling, can I do it? Absolutely. If this is something you like, go for it. More MiniMigs out there, the better. That's the whole story. Minimig.ca. And of course, MiniMig has a new case.
It's gorgeous.
Yeah, right?
Just hold it up.
Yeah.
Yeah.
There you go. Looks like that has its own little logo there. And expansion port, HDMI for PyStorm, of course. Truth to be told, I did design this, but there is a template in the factory in China where you can take your own board and you can just adjust the size easily, put your buttons and whatnot, put the logo and stuff. So it's quite easy to do this. It's all real aluminum. Even the little feet are made of aluminum, machined. So yeah, nice fit. One thing to mention: the first 50 board cases that I got, they're not quite perfect. I needed to print some standoffs and increase the hole size for certain things. But next batch will be better. But it did work after all. So after I mentioned that this Spartan 3 chip is kaput, it's out of end of life, and now it's time to kind of look further, move forward. But where I want to be, I'll certainly release a few more boards to kind of get enough knowledge to design what I really want to design and kind of learn more about AGA core and how all this fits together. So now we have a new board here, and this is 3 days old. Camera can capture it. It's called AmiCube.
3 days old.
3 days old. I was rushing it to get this all done, and when I powered it on, I was shocked and it's working. And it seems like it's working fine so far. The only mistake that I made, I kind of reversed the polarity of the LEDs. So when LED is off, it should be on, and when it's on, it should be off. That's something I can fix easily, right? Okay, so let's look into the board itself. So what it does 6820, it's 32-bit core FPGA at about 100 megahertz, which gives it a performance of 68040 at some 20-ish megahertz. The chip is, again, a little bit anachronistic, Cyclone 3, but much more modern part. It has 64 megs of SD-RAM. It uses surprisingly the same part for this as a system controller as MiniMig. It's this 8091 SEM7S 256, which is great for me because I already know the code in C. I can change the firmware easily, and that's the serendipity, I guess. And then the power can be a barrel jack as well here as MiniMig. You will see a lot of DNA from MiniMig. I kind of wanted this to be next gen MiniMig, and in any sense, I wanted this to be Amiga. So you'll see that certain things are the same. For example, the voltage regulation, the position of the fuse, and the power and the chips are in the same place. It's kind of similar. Then, of course, you can full voltage regulation is there. It has a MIDI interface, has the DB9 for, of course, joysticks. You can use original Amiga joysticks, Atari style. There's VGA here, then USB ports, 4 of them. You can use USB for the mouse, keyboard, and the joysticks as well. It will detect joystick and use it from the USB. Has this little thing here. This is audio video, so you have a regular barrel jack for your audio, and plus you have composite here. And depending on this crystal, it can be PAL or NTSC, whatever you prefer. Now I forgot, I mixed up the frequencies, and I was testing it, and I was thinking why it doesn't work, and then I realized I'm not in a PAL land anymore. This is all NTSC. So I was like, all right. Has a real-time clock. That's cool. You can see here battery as well. I don't know why is that a thing, but everyone's asking me about it, so I was like, okay, let's put it on. It's better to have it than not. Because this part is so, it's very, if you look at the Cyclone 3, most of the cores, Atari ST, Amiga, Commodore, PET, 64, everything is already ported for this thing, and I was able to find all these files for the MiSTer platform. I was able to compile most of it. So right now, this Amiga, and it is initially Amiga, can also run 50 different systems. So this can be your ZX, Sinclair ZX Spectrum, it can be Commodore, it can be many things, and it's all done in hardware, in FPGA. So it would be interesting to kind of compare this with the emulation. Should be much better, much more, how can I say, precise, much more accurate. So therefore, this thing here also has the tape in. So you can load your games from the cassette using the Sinclair core. And you can also extend this functionality to Amiga. So you can load stuff on Amiga using the tape, which is fun. Why not? Why limit it, right? So what else? Everything else is pretty much that I mentioned. Of course, because the chip is bigger, there is a support for Picasso 4 RTG. So this does rig targetable graphics and also does full AGA. So you can pretty much run anything on this. The entire Amiga collection of the games and demos will work just fine. And yeah, I think that's, I don't know if I'm missing something.
Headers?
Oh, headers, yes. So this one is for Wi-Fi, and it's totally compatible with the ESP32, so you don't need to solder or, bodge anything, you just put it on, that's it. What else I have here from the headers? Oh, here, okay. I have front panel, this thing here. So because it's ATX, if you put it in the PC case, you have all the LEDs and all the power on, power off button, whatever. Then there is a lot of debug stuff. This thing around the ARM part, it's to get the signals and see if everything's fine. If you want to put it to the logic analyzer. A lot of these debug pins will be removed. I just kept them. I usually, when I have a new board, I have a lot of debug stuff around, just so I can hook up cables and put it under the logic analyzer, see if everything's fine.
Do you have to remove them?
You don't. No, you don't. But at some point, I mean, if you really need to do some detecting, you can always hook up to the pin. No problem. It just looks nicer. But I mean.
You said the earlier versions had JTAG. Does this?
This one has JTAG.
Okay.
Yeah, it has a JTAG. Of course, that's something I need to keep because that way you can shoot the core directly over JTAG, so you don't need to put it on the SD card, right?
Yeah.
Yeah, JTAG is a must, absolutely.
Is it one core at a time?
Yes.
Okay. So
Yes.
there's not enough memory for multiple cores?
No, I mean it can on the SD card you can put as many cores as you like, and from the menu you can load any core. But I mean you can execute one core at a time. That's yeah. So yeah, that's about it.
Wait, before you go up that page,
Yes.
I gotta ask.
Yeah.
All the systems you support are in alphabetical order, and yet the Atari ST is at the end of the
That's an interesting.
Very should. Listen, this is very should be. You can always- Yeah. No, but in all honesty, I must say I'm one of those people who are, I love Mac, I love PC, I love Android. I cannot decide, and I was also an Atari user because I was always looking at the Falcon and all that good stuff. I loved Atari, especially for the design, the case. My God, those, the color and everything. But Amiga was Amiga. Come on. After all. Okay. So here you can see the performance, infamous sysinfo. Someone inaccurate, but I mean, within the sysinfo world, you understand what this means. It's above Amiga 3000, close to Amiga 4000. And what's interesting, take a look at the chip speed. This is bonkers. So that means your 3D games will fly like this. Well, that's a pretty good anomaly, I think. And then this is how RTG looks like on your screen, 800 by 600. And I think this is how God intended us to play double HD load games. I mean, this is it. Moving forward, I have a little video here so you guys can see better. So voltage regulation, you see LEDs for each level from 3.3 to 5 to 125 to 2.5 around here. And here MIDI ports. I don't know if I mentioned that. It has MIDI ports so you can connect your ST or Amiga or whatnot to your synthesizer and record stuff in the Cubase. VGA, of course, this is the hub for the USB. Then this is the PAL NTSC encoder, output for the signals, for the audio and video, if you want to use composite for whatever reason. Here, of course, it's Cyclone 3 that holds all these cores. Real-time clock with the battery. So these are parts for the real-time clock and the battery. Interestingly enough, I don't think I can stop. Let me see if I can go back. So here somewhere, I discovered these tiny little crystals. So now this is the first crystal that I'm using in 805 size. So usually when you deal with the crystals, they're like this big or like this big, right? So now this is probably what they use in the iWatch. So the crystals can be so small that you cannot even see them. For me, it's quite a formidable thing. And it's there, and that's what measures the real time.
Could I just ask you one quick question
Yes.
here? I noticed in your demonstration that you've got all these LEDs turned on. So does that mean the board is actually turned off?
Yes. So there is one LED that's on even when board is off. So this LED here, it's always on when you have ATX header on, because ATX is designed in such a way to have 5 volt standby.
Right.
And then you can see that LED running and being lit and thinking, oh, is it working? Actually, no. This is always on because here there is 555 chip that also has a trigger. This one here, and I'm using that one to trigger the ATX. So this one will get the signal from the power button and it will trigger entire board. So this, and then here it is, the blue one here. The blue one will always, they'll always be on because it's a standby, 5 volt standby. And then everything else, once you press the power button, it will light up as a Christmas tree, right? And it's nice when you put it in an acrylic case. It's really, really cool.
Yeah.
So yeah, I think that we can skip to another slide. You see this. So this is where we are right now. So this board is called A1200. Obviously, why not? I mean, it's AGA. 64 megs of RAM. The one that's going to be done within a month, it will have Cyclone 5. If you guys familiar, Cyclone 5 is in the MiSTer, which means this will improve Amiga performance and it will also give you ability to run everything to Nintendo 64. Like you'll be able to do PlayStation in hardware, Nintendo 64, and all these systems before. So that's kind of cool. And then A500, which won't be multi-core, I think, at the beginning. I don't think I will port anything there. Then Amiga. And the Cyclone 10 is the high-end part from the Intel, because Intel bought Altera, I don't know how you say it. And this part is serious. So this thing you can put PowerPC in it and bring it up a couple hundred megahertz, and you can run PowerPC Amigas. So that one will also have enough I/O and the pins that I can do the Zorro 2. I'll add floppy disk header, which is essential for the retro computer. We need to have a floppy. Without floppy, this is not. I mean, I bought some Amiga games now on floppy. I want to use that. Yeah. So A5000 will have that. We'll have floppy header, hard drive header. You can put your old Amiga hard drive, ID hard drive, hook it up. Ethernet, Wi-Fi, and most importantly, it will have 68,000 CPU socket, this time 32-bit. Entire architecture will be 32-bit, so performance will go up, and we can add 6060 right away and play with that, for example. Okay. So that's what's happening. So this is going to be a couple of months. Next time when I see you, I'll have this one, I'm sure. Because already I figured out the Zorro 2, which is super simple. This is, there's no special complications there. I already figured out how to pull out the signals from the Verilog to get the floppy working, because it's kind of implemented already. So there's nothing that can stop me. I mean, I already know what to do. I just need to put it all together. So, okay, so now, I don't know if you can say porn, but geek porn is good. I hope you're all above 18, so. Okay. SMT line. I design these things, but I also enjoy making them and producing these boards. So this is the recent purchase. This is what happened. This thing came in front of my garage, and I was thinking, how do I put this down? So there is a little platform, hydraulic platform, but the box was bigger than a platform, so it was quite a
oh boy.
How did you do it?
Yeah, how did you do it?
So,
brand new purchase?
Right, everything. So just piling, one thing after another. But you see this thing here. I think it's called pallet truck. It's hydraulic little thing for the pallet, and that it's useless when you're dealing with 1,000 kilograms of the equipment, right? Mm. So I bought this one, and I'm glad I did, because I can shuffle all my other stuff around, no problem. It's light, easy to use, it's super stable. So if you end up dealing with a big piece of machinery, whatever that is, this is something to consider. And it's not super expensive. I think it was maybe between $1,000 and $2,000, and it's all right. Yeah. Wow. It's hydraulic. It's really good. So okay, I brought you some things here. This is a Yamaha feeder. This thing is I think you said pneumatic, which means it works on the air. air comes here, and the air will open the shutter like this, and then machine will use these peaks and pick up the component and then place the component on the board. So this one is 8mm. It's a little beaten up, and that's why I'm using it everywhere, because it's more like for presentation. I also have electric feeders. They're 3 times more expensive, but the vibrations are much less. So if you have very small parts, you don't use this because this will shake a little bit. You use electric feeder, okay? And then I have much bigger stuff here. These things tend to be more expensive because they're so big and powerful. And what you do, you put the chips inside and the big parts. So this is 24mm feeder, and there's in between. There is 12, 16mm, whatnot, depending on the part size. So this is my machine fully loaded with the Yamaha feeders, ready to go. So if you have, each feeder is for a different component. If you have different value of the component, you put it in a different feeder. By the way, I didn't explain. The way it works, there is a reel here, and then there is a tape going there all the way down, and then there is another tape going all the way down here this way, and then every time the shutter opens and closes, this thing will rotate and bring another part out. So that's how it does. What can I do now? I can assemble an iPhone. I can. I really can. I can also produce hundreds, if even thousands of boards per day. I can do all sorts of crazy things. So that's why I need more boards than one, because I wanna use it. This is the other side of the machine that has these larger feeders for larger components. And this is a video. I don't know why it's upside down, but when I play, it's going to be okay. Hopefully. There you go. So this was the first ever run. So I was programming the machine, entering all the coordinates, the files. This is semi-automatic mode. You press play on the tape, and then what happens? The board comes inside. Machine will do the fiducial marks. These are fiducial marks on the board. It will adjust, and then it will kickstart the entire process. Where you can see these are deltas. So if every time you pick the component, it's slightly off, and if it's off, the machine will take that into consideration and it will adjust. So when you have the part on the board, it's dead accurate. It's 0.01 millimeter of precision. 18,000 components per hour, which is quite formidable. This is 60% of the speed. And the reason it's 60 is if I put 100% of the speed, my kitchen will start shaking. It's like 1,000 kilograms of powerful motors. These are Panasonic motors, and it's just scary. But this is fine for MiniMig and for our community to produce these boards. 60% is more than
Every garage needs one. What do your neighbors think?
They were looking at it when I was
Who is this guy?
At least you don't have to worry about neighbors coming over and say, hey, can I borrow your shovel when your shovel looks like that?
Where did it come from? Honey, I'm worried.
So after the components are placed, the idea that goes into a wave solder?
Oh, I'm going to explain it shortly. So it's usually people say wave soldering, but it's called a reflow oven.
Okay.
Wave soldering you use for through-hole components. So these are through-hole components, and there is a wave of the solder, and the board goes above the wave, and then you solder this. What I'm aiming for something now. It's called a selective soldering, which is similar thing. You have a little robotic arm with a little wave of the solder. Let's call it that way, like a volcano, and it will go selectively, because this board, this is the bottom side. You'll see there is SMD components there. So it can be tricky without the rigs, and I was explained today actually you can put the little of protection to still do the wave soldering. And you can see how precise it is. And this is even without adjusting the precision and being super inaccurate.
Anybody who's done soldering, that's hard.
Yeah. And you just put it in the, the offset that you see is because of my file, not because of the machine, because they're all a little bit offset. And you put it in this is very, the process is very flexible, because even if it's not what it should be, these forces, once you start doing the reflow oven, the forces will pull the component in place. It's quite gratifying to see the process because everything, it's like that liquid Terminator. It's everything goes where it should be. It's quite something. So yeah, so that was the first run. Large components, they go on the tray. So you don't put this into the feeder because it's huge and heavy. So there is a place in the machine where you put the tray, and then machine knows where it has like the matrix of the components and know which component was already used, placed, and it will go accordingly. Here you can see a special camera. This is not high-speed camera. This is a precision camera for large components, and this camera is used for big parts. With a lot of pins, and the software will determine the exact, really precise precision. So if you make a little mistake, if you ever seen these pins up close, they're so tiny you can barely see them.
Yeah.
If you mess up that part, then you can easily rework the entire board. You don't want to do that. So a couple of other things, the compressor needs to be non-oil lubricated, whatever that means. Because you can
Can't have that spraying.
you can put the oil inside of your feeders. That's not what you want to do. So this is the one that was created. And these feet are industrial feet. They actually absorb the vibrations, and also this big nut here is used to adjust the height. So that's also funny. I never seen that. I didn't know what to do with it when the machine came, and then I realized, okay, this is it.
What are those feet made out of?
They're all very, very strong metal, but they have very strange material in between. That's some sort of very thick and very, durable rubber or something. That's how it feels like. All right. To answer your question, this is called stencil printer. So what you do, you put the board here on those little pins. You put the stencil between these black arms here. And then you add a little bit of solder paste, and then these squeegees will go down and put the solder wherever the solder needs to be. So solder needs to be on the pads. These are pads, right? For the pins and for the resistors, and then after this first part, the board goes into pick and place machine, which you already saw, and then finally goes into the reflow oven. This is a small reflow oven, quite neoden. But it does the job for me because you can set up very precise profile here. So the board the temperature will go high quickly, and then it will stay there for a while and then slowly cool down. And that will make all this Terminator thing happen. It will pull the components and cool down and make everything in place. So I think that's about it. Yeah?
Yeah.
Price.
Any question? Okay.
Are you put HDMI on the board eventually?
So, yeah, absolutely. I mean, even now I can do the HDMI. It's just one chip in the port. It's not a problem. But the reason I kept VGA because maybe that's, I don't know if it's a good or bad decision, but it is a retro computer, and most of the people who are already buying MiniMig, they're kind of into the VGA stuff. VGA, RGB, similar, Amiga monitors, things like that. So you kind of want to stay in the retro area as well. But I think HDMI is a must because we all have HDMI TVs, and we want to add this to the living room or whatever, to play these games. Especially now with the USB, you can do wireless joysticks, so you can just put this in the bottom, and then from the bed you can play, your games.
But this one here has HDMI out.
It does, yeah.
Okay, it already has it.
No, sorry. This one.
No, I mean the one you're showing.
Yes.
Yeah.
So this one has, and the reason this one has, this is the MiniMig latest version, is because this one is running PyStorm. PyStorm has HDMI, so that's the flexibility. Having MiniMig with the socket is a big deal. You can add all these things that other people in the community are making. This PyStorm project is mind-blowing. They created this interface board and the software that transforms the Raspberry Pi into high-end 68,000 CPU. For me, that's like, wow. So I'd definitely keep that functionality for the final board. We'll have all that stuff added.
Can you add more lead to the solder?
So
You know what I'm talking about, right?
Everything I'm using is non-lead
Yeah.
because you don't want lead in your house.
Well, I mean, I'm okay with it on the board. I'm not melting it down though.
Well, the problem is when you're using the paste, the solder paste, it's so sticky, it goes everywhere.
Yeah.
And I was like,
So
first,
it's easier to work with the silver solder than
the lead is easier to solder. I mean, it
found
has a better performance in terms of, whatever.
production.
Yeah, definitely it's easier. But I mean, it's not that much different to kind of justify having such a toxic substance in your house.
He's running it out of his garage.
Yeah.
No, I get it. It's like to me, like the parts that fail on a board, MOSFETs, the cracking that happens in the solder because of lack of the lead that they used to have in the older. That's why we have Amigas that still run today in our Commodores. Because there's lead in that freaking thing, you know.
Right.
It's not gonna fall apart. And
I wouldn't say that.
well, I mean, it's a factor, right? So, and when they reflow their boards to fix that cracking on those boards, like I did a lot of auto builds, and I see cracking all the time.
Right.
Lead, I'm always adding lead. You know what I'm saying?
More lead, more asbestos.
Well, well, to me, it's not coming back.
Yeah.
I don't think it's.
So there is something to be said about that. You're right. But the thing is, when it comes to these solder paste, there is a T3, T4, T5. Depends on the size of the ball inside of the solder paste. If you put it in a microscope, it looks so funny. It's like a lot of little balls.
It's got the mixture in there, right?
Exactly. But there's also the new stuff is high performance. It's the mixture of different elements, and it's really good. Like, I mean, I'm not expect this to crack anytime soon. And if it does, it's all made of onion parts, so I can replace.
I was gonna say, if it's cracking that easily, then you've got a lot of hot parts.
Well,
yeah, it's true. That's a good
I'm using the same thing that you're using in an iPhone, so it's T5 from
And it's open source, so if you wanted to build it yourself and use lead, knock yourself out.
Yeah.
No, like I'm like when I'm redoing boards, like when I'm looking at boards that have failed in like in a car or something, I'm always seeing those cracks, and I'm doing solder. And plus, you can easily just heat it up, like take your heat gun or solder, rework the whole board and stuff. But the problem is that solder gets less on the board. You guys know about that?
Yeah.
How it gets less, and eventually it just stops working again. It's just that's a downside. I try to do stuff that lasts, right? I mean, and I'm not one to think I am just some cheesy guy.
Join the club.
Trying to save some money there, for some people. And
All right. Any other question? The price. Chris is asking about the price. So for this board in particular, if you're talking about this one, I'm going to try to make it super cheap. Like it has less parts than MiniMig. It has newer parts. So depending how many parts I buy and where, it can be even sub $200, which is quite cheap.
Selling.
Yeah.
Price more.
So that's the whole idea. Make it like in large quantities, make it super cheap so everyone can buy it.
We need to protect them.
So that's one thing. The other thing is talking about Altera 5 and Cyclone 5 and Cyclone 10. I know for certain that Cyclone 10 will be expensive. That's the high-end part from the Intel, and this thing can eat kids. You can put entire modern CPU inside, so I don't think that this will be cheap, but I also going to try to make it as cheap as possible. Cyclone 5, I don't think that will be crazy. This is the same part as I mentioned in MiSTer, so it's out there, it's commonly available, so a couple hundreds of dollars, I would say, kind of like MiniMig right now. So that's what I'm hoping for.
Probably a dumb question, but how about having two crystals and a switch so it can go between NTSC and Alpha?
Yeah, I can do that easily. Just level switch. That's a good idea. Because now I need to desolder and put a new one.
Next forward revision.
And if you look at the location of the crystal, there's quite a lot of space. In fact, you can create a board like this in a quarter of the space, right? First of all, I'm not using this side, the bottom side, and the reason is it's much easier to produce a board like this because you don't need to do two processes, you do only one. And also with the soldering of the through-hole components, you use just a wave soldering. You don't need to use selective soldering, which is more time-consuming and setup is involved and so forth. So yeah, that's one thing. So there is a place for a lot of things here.